Today we are going to go over questions 1 through 6 on Exam 2, Part 1. Question 1. What is the specific internal energy in kilojoules over kilogram of superheated vapor R134A at 240 kilopascals, 20 degrees Celsius? We will use table D3 since we are looking at R134A and its phase is superheated vapor. Locating a temperature of 20 degrees Celsius and a pressure of 240 kilopascals, the specific internal energy can be determined. In this case, the specific internal energy was found to be 244.3 kilojoules over kilogram. Question 2. What is the specific enthalpy in kilojoules over kilogram of saturated liquid water at 180 kilopascals? Using table C2 and locating a pressure of 0.18 megapascals, the enthalpy can be determined. Since the phase is saturated liquid, we will use HF. The specific enthalpy is found to be 490.7 kilojoules over kilogram. Question 3. What is the specific internal energy in kilojoules over kilogram for the ideal gas air at 1500 Kelvin? We will use table E1 for properties of air. Locating a temperature of 1500 Kelvin, the specific internal energy can be determined. In this case, it was found to be 1205.41 kilojoules over kilogram. Question 4. What is the specific enthalpy in kilojoules over kilogram for the ideal gas air at 387 degrees Celsius? Again, we will use table E1 for properties of air. Converting the temperature from Celsius to Kelvin, we can locate the specific enthalpy for a temperature of 660 Kelvin. In this case, it was found to be 670.47 kilojoules over kilogram. Question 5. What is the specific internal energy in kilojoules over kilogram for the ideal gas carbon dioxide CO2 at 1140 Kelvin? Using table E4 for properties of carbon dioxide, the specific internal energy can be determined. Locating a temperature of 1140 Kelvin, the specific internal energy is found to be 41,006 kilojoules over kilomole. In order to convert the units to kilojoules over kilogram, table B2 can be used to locate the molecular mass of carbon dioxide. Using the conversion factor, the specific internal energy is determined to be 931.74 kilojoules over kilogram. Question 6. What is the constant pressure, specific heat, in kilojoules over kilogram per Kelvin for the ideal gas neon? We can use table B2 to determine the property constant pressure specific heat Cp for the ideal gas neon. In this case, it is found to be 1.02 kilojoules over kilogram per Kelvin.